Hey everyone, and welcome back to my channel. So I had said before the school closure had taken place, we were going to pause with trig, and we moved on to our matrices unit. However, with school still being closed, we still need to continue with trigonometry, so we are going to come back and resume with that unit. So this is our last section for the trigonometry unit, all right? We're going to be proving trig identities and solving trigonometric equations. So today's lesson is going to be on solving trig equations in the first and second degree. So I'm just going to scroll through. We're going to do a few practice problems here. So I want us to take a look at exercise 3. So it says solve over the interval from 0 to 2 pi and round to the nearest hundredth when necessary. So when solving trigonometric functions, all right, notice how the first equation that I gave you is quadratic due to the squared. So there's a squared right here. You have to remember, how do you solve a quadratic function? Awesome. So we solve quadratic functions by setting them equal to 0. So we're going to subtract over this 2 to set this thing equal to 0. So I'll have 3 cosine squared theta minus 5 cosine theta minus 2 equals 0. Now notice it says round to the nearest hundredth when necessary, so I'm probably going to want to use the quadratic formula here. Now the way that you're looking at this, you're probably maybe wondering, well, how is this going to be used for the quadratic formula? Well, if you guys think about it, if I said let cosine of theta equal x, I'm just doing a substitution here. If I let the cosine of theta equal x, well, here I would have 3x squared minus 5x minus 2 equals 0. And that's a nice quadratic you know how to solve. So let's plug into the quadratic formula. We have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, when you just put that into the calculator, all right, I'll have x equals 5 plus or minus the square root of, we have 25 minus 12 times negative 2, so that's 25 plus 24. So this is the square root of 49 all over 6. And I'm just going to write this over here. So I'll have x equals 5 plus or minus 7 over 6. We'll split our terms. We'll have x equals 5 plus 7 is 12. So I have 12 over 6, which is 2. And then I also have 5 minus 7, which is negative 2. Negative 2 over 6 is negative 1/3. So you guys just have to go back and remember, we said x was equal to the cosine of theta. So that really means we have the cosine of theta is equal to 2, and the cosine of theta is equal to negative 1/3. We just did a substitution here to make our lives a little bit easier. So now I'm just going to type this into the calculator. All right, so like I said, we're going to plug this into the calculator. So I'm just going to erase what I have here just to make some space. We want to figure out what is the cosine inverse. So I'll write that here. We want to know what's the cosine inverse of 2 and what's the cosine inverse of negative 1/3. Now remember, we're taking inverse trig because we're looking for an angle measure. We're trying to find theta. Whenever you're trying to find an angle measure, we use inverse trigonometry. Now, this should be alarming to you. Cosine inverse of 2. This doesn't exist. That's the empty set. It doesn't exist. You can't take cosine inverse of something bigger than 1 or smaller than negative 1. So this value has to be between negative 1 and 1, right? If you think about the unit circle. If you think about the unit circle, the biggest cosine can be is 1, 0, and then you have negative 1, 0. So the biggest values for cosine are 1 and negative 1. So this doesn't exist, so that's out. Cosine inverse of negative 1/3, well, I'm just going to type that in the calc, and I end up getting and I did this in radians, so make sure you're in radian mode, I got 1.91. But now we're not done. If you guys remember, okay, no, this is a little bit a while ago. If we have our ASTC, all students take calc, I want to know where is cosine negative. Well, cosine is negative in the second quadrant and the third quadrant, right? Because I'm trying to find out where cosine is negative. So these are out. So if I have 1.91, well, that's indicating this length here in the second quadrant. So if this has a total length of 1.91, and you guys have to remember, because we want to figure out what the reference angle is, we estimate this value here to be 3.14, right? Because this is equal to pi. So I'm going to subtract them to figure out what the reference angle is. So if I take 3.14 and subtract it from 1.91, let's see what we get. You should end up getting 1.23. So that's the reference angle in radians. So if I know the reference angle in radians here is 1.23, well, then I know the reference angle here in radians is also 1.23. And I am further past pi. Remember, pi is at 180 degrees, which is equivalent to 3.14. We're rounding. So I'm going to add 3.14 with 1.23 to get the other angle measure here in radians. So when I add those together, I end up getting 4.37. So when it says round to the nearest hundredth, our values for theta are 1.91 and 4.37 radians. Okay, so that's just one example. All right, let's just take a look at another one just to get you guys some more practice with this. All right, let's take a look at exercise B here, and then we're going to move on from this. So again, this is a quadratic equation because of the squared for sine theta. So again, if you want to, if it's easier for you, we can rewrite this as saying let x equal sine theta. So if it's easier for you to identify, this is really x squared minus 5x plus 3 equals 0. And we're solving a standard quadratic. Now this is not going to factor nicely, so again, we're going to use the quadratic formula, where I have x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times 3 all over 2 times 1. I'll have x equals 5 plus or minus the square root of. Here I have 25 minus 12, which is 13, all over 2. And these are now my two solutions. Remember, we said x equals sine theta, so I'm going to write here sine theta equals 5 plus rad 13 over 2, and sine theta equals 5 minus rad 13 over 2. Now we're solving for theta. So remember, when you solve for an angle measure, we have to use inverse trig. So I'm going to use sine inverse of this value and sine inverse of this value. So let's write that out. All right, and I'm just typing these both into the calculator. So let's do sine inverse of 5 plus rad 13 over 2. And let's see what we get. It doesn't exist. So that means this is the empty set. This does not exist. All right, let's check the next one. We have sine inverse of 5 minus rad 13 over 2. And when we plug that into the calculator, I get 0.77 for theta. Now remember, I did this in radian mode because if we read above, this wanted this over this interval between 0 and 2 pi, which means I should be using radians. Okay, so that means that's my reference angle. So sine inverse of this value, which just so you guys know, if I were to have simplified this in the calculator, that would end up being 0.70. Okay, so again, that value is between -1 and 1, so that's good. And we're going to have two values. Remember, sine is positive in two quadrants. All students take calc. So we know sine is positive in the first quadrant and the second quadrant. So if we know the reference angle is 0.77, all right, and this again is in radians. I know it's a little weird. So the reference angle here is 0.77. Well, I want to know what this value is here. Again, a reference angle of 0.77. If you recall what I just said earlier, this value here we go. This length here is 3.14 because that's equivalent to pi. So if I take 3.14 and I subtract out this reference angle, so if I subtract out the 0.77, I'll get what this entire angle measure is equivalent to. Okay, so we'll say that one more time. If I take pi, and I subtract pi, this entire length of pi, from this reference angle here, I will end up with my total measure of the angle in the second quadrant. So if I have 3.14 minus 0.77, you end up getting 2.37. And this is all in radians, guys. So my two angle measures for sine are 0.77 and 2.37. And this is all radians. Okay? All right, so let's move on from this. So example letter C is just extra practice, but we're going to move on. I want us to take a look on the next page of your packet. We're going to be looking at question 1. Solve the trigonometric function by isolating the trig equation. And we're going to be solving it over the interval from 0 to 2 pi. So remember, we're looking at radians again, so keep your calc in radian mode. So now I'm going to solve this quadratic equation first by bringing over the positive 4. Okay, so now I have 3 cosecant squared of theta is equal to 4. I want to get rid of the squared, but before I can get rid of the squared here, we need to divide out by 3. So let's divide out by 3 on both sides. And now I have cosecant squared of theta is equal to 4 over 3. To get rid of a squared, we square root. So I'm going to square root both sides. And don't forget your plus or minus. So we'll have cosecant of theta is equal to plus or minus. Square root of 4 is 2. So I'll have 2 over radical 3. All right, but now I want to get that into simpler terms here for us. I don't like dealing with cosecant. I want to look at its reciprocal trig function. The reciprocal of cosecant is sine. So this is equivalent to sine theta being plus or minus the square root of 3 over 2. Now, this should be ringing a bell here of what is the reference angle that gets us to rad 3 over 2. So now we have two situations here. We have sine theta is equal to positive rad 3 over 2, and then sine theta is equal to negative rad 3 over 2. So I want to know, where is sine positive and negative? Well, sine is positive and negative in all of the quadrants. So sine being positive is in these two quadrants, and sine being negative is in these two quadrants. Okay? So, wait, it's color-coded here for you. So sine of what gets us rad 3 over 2? What's that angle measure in radians? Sine of what gets us rad 3 over 2? Okay, so if you want to think about it in terms of degrees, for those of you that might be easier for, sine of 60 degrees is equal to rad 3 over 2. So it might be helpful for you guys to have that table written down. So I'll write that here again for us. So we'll have sine, cosine, tangent. All right, I would pause the video here and see if you can fill out this table yourself. Okay, so that's what our table looks like. So if I'm looking at the sine of what gets me to rad 3 over 2, well, if I look over here, sine of theta that gets me to rad 3 over 2 is pi over 3. So the reference angle for us is pi over 3. So I know in this quadrant, I'm looking at pi over 3. In this quadrant, remember you take 1 less than the quadrantal angle of pi, so this would be 2 pi over 3. So here I have theta is equal to pi over 3, 2 pi over 3. We're not done though, because now we need to deal with what I have circled here in green, or boxed in green. Now we want to know what those reference angles are here. Well, they all still have the same reference angle of pi over 3. So the angle measure here in the third quadrant would be 4 pi over 3. And then lastly, this would be 5 pi over 3. So I'll have theta also equals 4 pi over 3 and 5 pi over 3. Let's see, fit that on here. Okay. All right. So those are my 4 angle measures. You have theta equals pi over 3, 2 pi over 3, and then 4 pi over 3 and 5 pi over 3. So you have 4 angle measures. Okay? There you have it. I just circled it there for you here in black. Okay? All right, let's move on. Why don't we take a look at this first example right here. So let's take a look at question 2, letter A. All right, so I have cosine squared sine theta minus sine theta. Okay? So first things first, I'm going to take out a GCF, right? We're going to solve this by factoring. So I'm going to take out a sine theta here, and I'm going to take out a sine theta here. So I'll have sine theta times cosine squared theta minus 1 equals 0. Okay, let's t-chart this. So we'll t-chart. We'll have sine theta equals 0, and I'll have cosine squared theta minus 1 equals 0. So let's add over the 1. So we'll have cosine squared theta equals 1. Now we want to square root both sides to get rid of this squared. So we got to square root both sides. We'll have cosine of theta equals plus or minus 1. Okay, well, let's look at the unit circle. We want to know where is sine of theta equal to 0. So let's label all of our points here. Okay, where does sine have a value of 0? Where does sine have a value of 0? Sine has a value of 0. Remember, it goes cosine, comma, sine. Cosine comes first. Think of the alphabet. X, then Y. C, then S. Okay, so sine has a value of 0 here and here. So that's at 0 or 2 pi, and then also pi. But now just note the interval that I gave you earlier. I wrote it as the directions up top. The directions up top here said we want it to be over the interval from 0 to 2 pi, where you do not include 2 pi. So you're not including 2 pi. So really, I'm just looking at 0 and pi here. Okay, we're not including 2 pi. So I have 0 and pi. And let's see, where does cosine equal 1? So let's look, where does cosine equal 1? Well, cosine is equal to 1 here. And where does cosine equal negative 1? That's here. So it's actually still the same values. You're still looking at 0 and pi. Okay? So those are my solutions. Those are my values for theta. We solved the quadratic of a trigonometric equation. Okay? All right, now let's take a look at example letter B. So now we're going to actually do some practice with factoring. I know some of you guys prefer doing tricky trinomial. However you prefer to do it is totally fine. I'm going to be doing this by grouping. Okay? So first things first, again, if it's easier for you to recognize that sine of theta, if you want to use a variable to replace it, we can say sine of theta equals x. So let's do a little replacement here. So now I have 2x squared minus x equals 3. Remember, when we solve a quadratic, we got to set it equal to 0. So I'm going to subtract 3 over on both sides. So I'll have 2x squared minus x minus 3 equals 0. Now, notice that our leading coefficient here is not 1. So we have to do either tricky trinomial method or factor it by grouping. So I'm going to do my factor by grouping method. I want to see what's going to multiply to negative 6x squared, but adds to negative 1. So what multiplies to negative 6x squared, but adds to negative 1? Well, we would have negative 3x and positive 2x. So I'm going to split the middle here. I have 2x squared plus 2x minus 3x minus 3 equals 0. I'm going to group by taking out the GCF of the first two terms. So I'm going to take out a 2x. I'll be left with x plus 1. Take out a negative 3, and I'll be left with x plus 1 equals 0. We're going to group our terms. So I'll have 2x minus 3 times x plus 1 equals 0. All right, and these got grouped together. Okay, so now we just need to solve. We can t-chart this now. So when I t-chart, I'll have 2x minus 3 equals 0. Here I'm just going to do some quick math here. You know x is going to equal negative 1. All right, add over the 3, and I'll have 2x equals 3, divide by 2, and I'll have x equals 3 over 2. But now remember, we made this substitution up here, that sine of theta is equal to x, so you need to go back and replace it. So I'm going to substitute in. We know that sine of theta equals 3 over 2, and I also have sine of theta equals negative 1. All right, remember we just did that little substitution here to make the algebra a little bit easier for ourselves. Well, remember what I said. The value for sine can only be between negative 1 and positive 1. Similarly for cosine. Cosine can only be between negative 1 and positive 1. You're looking at sine of theta equaling 1.5. This can't happen. So this solution is out. We reject it. Well, now let's see, where is sine of theta equal to negative 1? I'll draw my unit circle again. Where does sine of theta equal negative 1? And the only place where sine of theta is equal to negative 1 is at 270 degrees or 3 pi over 2. Okay? All right, let's keep going. Just get more practice with this stuff. We're just solving trig equations. All right, so let's look at some more basic one-step equations here. These actually I think you guys will find to be a little bit easier. So if I look to solve each of the following for the values in the interval from 0 to 360, and we're going to be using degrees now. So I would switch your calculator now to degree mode. You guys just have to read. If it has pi here from 0 to 2 pi, you should be in radian mode. But here I'm looking at degrees, so I'm going to change to degree mode. All right? All right, so I want to know sine of x equals 1. Well, we're solving for x. That's an angle measure. So we're taking sine inverse of 1. Sine inverse of 1 will equal our angle measure. And now this is not something you need to type in the calculator, guys. You should know your unit circle. So I have 0, 1, negative 1, 0. And then 0, negative 1. The only value where sine is equal to 1, remember sine is the y values. The only value where sine is 1 is at 90 degrees. So that would just be 90 degrees. All right, let's take a look at example 3 here. We want to get theta by itself. So first let's divide by 2 on both sides. So now I have sine theta equals a half. Remember, you're solving for that angle measure. So we're taking inverse trig. Sine inverse of a half. So we got to remember, sine of what gets me to a half? And if you need to, refer back to your chart here. This is not something really you should be using a calculator for. Sine of what gets me to a half? So we're looking at sine here. Sine of pi over 6 gets me to a half. So pi over 6, we have to remember, is 30 degrees. So that's 30 degrees. But I want it over this entire interval. So we have to remember, all students take calculus. Right now, all you did was tell me about the first quadrant. Sine is also positive in the second quadrant. So if I have 30 degrees here, and this has a reference angle here also of 30 degrees, we know this entire length is going to be 150. Because if I did the math here, 180 minus 30 is 150. So we have 30 degrees and 150 degrees. That's for question 3. Okay, let's just do a few more like this and you guys should be good to go. Let's take a look at question 6 here. So again, we want to subtract over the 1. So let's subtract 1 to the other side. Now I have secant theta is equal to negative 1. I don't like using the reciprocal trig function, so I'm going to change this to a trig function that I do like, which is cosine. So the reciprocal of secant is cosine. And now this is really negative 1 over 1. So when we take the reciprocal trig function, we have to flip it. So this is now 1 over negative 1, which, guys, that's still just negative 1. Okay? So where does cosine equal negative 1? Well, again, just looking at my unit circle, cosine is negative 1 at 180 degrees. So right there. Boom. That's it. Okay? I would pause the video here and see if you can give 7 and 8 a try on your own. So pause the video here and give 7 and 8 a try on your own, and I'll post the solutions. Okay, and there you have your solutions for 7 and 8. So for 7, you should have gotten 60 degrees and 120 degrees. Knowing that sine of what gets you to rad 3 over 2, that would be the sine of 60 degrees. That's the reference angle. You have to remember, sine is positive, so you're looking in the first and second quadrant. And then for question 8, we end up finding cosine to be negative 1/2. So you need to know cosine is negative in the second and third quadrant. So those are the two places that I'm looking. Again, if you remember from your table, cosine of what gets me to positive 1/2? Well, the cosine of 60 degrees is 1/2. Cosine of 60 degrees is 1/2. So that's the reference angle. Okay, and I'm looking at it being negative, so that's why we're looking at the second and third quadrant. So I'll have 120 degrees and 240 degrees. Okay, let's just keep going. We're just getting a lot of practice in here. All right, so I'm going to flip over to our next page, and let's take a look at, I'm actually going to flip over to 2 pages. We're going to take a look at questions 13 and 14. All right, so again, we're just solving for x. These are now just regular equations. They're not quadratic. There's no squared. So for the first question here, for 13, I'm probably going to want to divide by that rad 3 on both sides. So now I have the secant of x is equal to 2 over rad 3. And I don't like dealing with the reciprocal trig function, so I'm going to change this. The reciprocal trig function for secant is cosine. And remember, we flip the fraction, so it's just rad 3 over 2. So cosine of what gets me rad 3 over 2? And again, cosine is positive, so we're looking in the first and fourth quadrant. So the cosine of what gets me rad 3 over 2? So you got to know that that reference angle is 30 degrees. So I'm looking at 30 degrees, and so that's 30 degrees here, 30 degrees here, and then this would be 330 degrees. Okay? And quickly, let's take a look at question 14, because we haven't done any with tangent. So again, I'm going to add that rad 3 to both sides, and I'll have tangent of x equals rad 3. So the tangent of what gets me rad 3? And now again, tangent's positive. So we're looking in the first and third quadrant. So tangent of what is rad 3? So you need to know that that reference angle, so x's reference angle is 60 degrees. So I'm looking at 60 degrees being one of the angles. And I'm in the third quadrant here, so 180 plus 60, that's 240 degrees. Okay, those are my angle values. All right, so I'm just going to flip through. Let's take a look at, on the same page, I believe this is. Yep, same page, and let's take a look at questions 19 and 20. Okay, so for 19 and 20, again, if you want to try to pause the video here and see if you can try these questions on your own. But remember, we're always trying to look to see if we can factor. So pause the video here. All right, and there you guys have your solutions for questions 19 and 20. So I just want to wrap up. Again, this is all just practice for you guys. If you think you've already gotten the hang of it, you can get started on that homework. But I do want to take a look on the next page on questions 21 and 22. Okay, so 21 and 22. So, but the solutions are here if you want to pause the video and just make sure you're all good. But let's take a look at 21 and 22. So we have quadratic equations that we're solving. So we always want to see if we can factor first. Again, if it's easier for you to replace the trigonometric function by saying, hey, let tan x just equal, I don't know, pick a variable, y. Let tan x equal y. So you'd have y squared minus 3y minus 4 equals 0. So if it's easier for you to replace the variable to understand that this is still a quadratic, let's factor it. So what multiplies to negative 4 but adds to negative 3? We'd have negative 4 and positive 1. And we're just going to t-chart. So I have y minus 4 equals 0 and y plus 1 equals 0. I'll have y equals 4 and y equals negative 1. Remembering we substituted in y to be tangent of x. So really I have tangent of x equals 4. And here I have tangent of x equals negative 1. Now remember, when we're solving for angle measures, we use inverse trig. So I'm going to do tan inverse on 4. And I'm also going to take tan inverse on negative 1. And I'm going to type these both in the calculator. And I believe that I wanted these left in radians. So let's do it in radians. Okay, so tangent inverse of 4 is approximately 1.33. Now, you guys have to remember, if I were to draw my axes, right? All students take calc, and I want to know where tangent's positive, so that's here and here. If I have 1.33, well, you need to remember that this value here represents 3.14, this represents 6.28, this represents 4.71, and this represents 1.57. So 1.33 means that we just found, so a reference angle of 1.33, that means we're in this quadrant here. So I have 1.33. So that's taken care of here for A. We're in the first quadrant. But I'm also looking in the third quadrant. So if my reference angle, again, is 1.33, let me draw that better here. 1.33, well, I just have to add that to the 3.41 to get that radian value. So we end up getting 4.47 radians. So we'll have, whereas tan inverse equal to 4, so tan inverse of 4, we'll have our angle values are, I'll write this here, we'll have x equals 1.33, this is all in radians, and then 4.47 radians. So that just takes care of tan inverse of 4. Tan inverse of negative 1, well, you guys should know this. Now I'm looking at where is tangent negative. So let me draw now another example here. So I have all students take calc. I want to know where tangent's negative, so I'm looking at here and here, right? So you should remember the reference angle for tangent being 1. Well, that reference angle is 45 degrees, or pi over 4. That's the reference angle. So if my reference angle is 45 degrees and I'm in the second and the fourth quadrant, well, I know that this radian measure here will be 3 pi over 4. That's 1. And then this measure here will be 7 pi over 4. So there you guys have it. X equals 1.33 radians, 4.47, 3 pi over 4 radians, and 7 pi over 4 radians. Okay? Awesome. Alrighty, let's just take a look at question 22 and then we are done. Again, this is all practice, guys. If you already understand this, you don't need to be paying attention to me here. You can just get started with that homework. Alright, so I'm just going to erase what I got here and let's look at question 22. Alright, so last question of the day here. We see that this is a quadratic, so we're going to set it equal to 0. So let's subtract over that cosine of x. So I'll have 2 cosine squared of x minus the cosine of x equals 0. I'm going to factor, so let's take out that cosine of x, take out that GCF. So I have cosine of x times 2 cosine of x minus 1 equals 0. And we're going to t-chart. We'll have the cosine of x equals 0. I have 2 cosine, hang on. I have 2 cosine of x equals positive 1, just bringing that over. Divide by 2, and all of cosine of x is equal to 1/2. So these are my two values. Where does cosine equal 0? So we'll have that at 0, 1, and then 0, -1, right? Cosine is equal to 0 here. So that's at pi over 2 and 3 pi over 2. So there's two angle measures. That satisfies this equation. And now let's take a look. When does cosine equal a half? Well, cosine is equal to a half when x is equal to 60 degrees or pi over 3. So if we look at our quadrants, all students take calc. I'm looking at the first and the fourth quadrant. So I know my reference angle here is pi over 3. And I know my angle in the fourth quadrant here will be 5 pi over 3. So there you guys have it. Those are your four angles. So if I write that out more formally, you'll have x equals pi over 2, 3 pi over 2, pi over 3, and 5 pi over 3. All right, guys, I hope you guys found this video helpful. Stay tuned for some Zoom sessions and extra help on this stuff as well. You'll have another video just doing more practice problems with this, all right? Talk to you guys later.